And welcome to Ladyada.
Hey everybody, and welcome to yet another Desk of Ladyada. It's me, Ladyada, here at my desk. With me is Mr. Ladyada on camera control behind the scenes, making all this go. Make it go, Mr. Ladyada. Make it go.
All right. Yeah.
Okay. Well, we had a big week this week.
There was a lot going on.
Yeah.
So for the folks who always ask, can I visit Adafruit? That was always hard to do in the past. Even harder now, as you can imagine.
Yeah.
Because
COVID.
We're going to be at 100% vaccinated shortly. But anyways, it's always hard to do. But we've been doing virtual tours for a while. So this week was manufacturing. It was manufacturing week, and then it was also made in New York City. So if you go to our press section, adafruit.com/press, that's the easiest way to do it. There's a blog post that has all the things about Made in New York City week. And then October 1st was Manufacturing Day. So if you can click over to the other tab.
Yeah.
We have a video that we did live from Adafruit on Friday and scrubbed through this. So you could see us at the factory live. Okay, and then we talked about some Adafruit history. And then we had a video run through, kind of like a speed round of all of the places that we have in our building and all the different things we do. So from shipping to manufacturing, we have a special robotic camera on one of the floors. And then we have a run through and a walkthrough where we talk about all the different things. So since folks always ask, or they're like, I want a factory tour.
This is it.
This is yet another one, and we're going to continue to do these. So anyhow, and then Ladyada talks about testers and more, and it was a little bit like Desk of Ladyada, just so y'all know. So I figured that would be a good way to talk about manufacturing in the USA, which is in the news all the time. And I'll say it straight up, like we hear this every 5 years, and really nothing comes out of it. And now everyone's like, oh yeah, like Adafruit manufacturers, like you guys are engineering heroes, manufacturing heroes. But the reality is we're not the heroes anyone wanted, but we're the heroes he got. So you just got to deal with it, dudes. That's just how it is. We're weirdos, and I know you wanted someone else, but this is how it is. So, anywho, we have stuff that you're working on this week, right?
Yeah. Okay, so that was me scrolling through, showing the video, but to watch the whole video, it's 30 minutes long.
Yeah.
People asked live questions, we answered them, much like our shows in general, but this time it was at the Adafruit factory.
Yep.
Okay, so that's that. So check that out, adafruit.com/press. Okay, so this week, last week we talked about sensors that have the same pinout and how wonderful that is because it makes it so easy to manufacture new boards without having to get new stencils, without having to change testers, without having to change the pick and place program, especially the stencil, which is kind of it's not expensive, but they're like $300 or so. So you really don't want to, and they're big. You don't want to get them unless you need them. So. We talked about the ADXL series, SPI I2C accelerometers, and I also was like, I forgot about the VL53L0X and the VL53L1X. These are two time-of-flight proximity sensors that have the same pinout, although they look quite different. These are both from ST, and what's funny is you can't get anything from ST right now, but you can get these sensors. So I was like, you know what? While I'm waiting for the silicon shortage to end, maybe. Let's spin up a board, and I think I showed that last week where I just changed the silkscreen from 53L0X to 53L1X. So the next step is to do a tester, and I actually realized I don't think I'd ever shown exactly how I code up a tester. So you go to the overhead, and I'll show how I physically, this I've showed physical tester builds. So let me focus in. Come on, hold on.
It's funny, when the overhead's not focused in, it looks like those dream sequences on soap operas.
Ooh, yeah, it's like I'm
Todd, you're really my father after all these years, Todd.
So I've shown these testers before. I tend to use a Metro just because, it has everything, the power regulation, the power switches, LEDs built in. I'd love to use Arduinos and Arduino-shaped boards and Teensies as the base. And then this is the shield that goes on top. So this one is actually, it's a recycling of the, again, BL53L0X sensor. And because it's the same pinout and shape, I can just recycle the board. One of the nice things about moving to the STEMMA QT format is almost all the boards I have are now the same size. They're 1 inch by 0.7 inch. Which means I can really reuse a lot of testers, which is that's another thing that I don't have to do. Reducing the friction is the name of the game. Then, this has a little standoff, but normally, sorry. So you press this button to, this is the reset button. So another nice thing, at Mega 328's reset very quickly. And then you press the board down to perform the test procedure. And in this case, you see that green LED blink. I usually also have the piezo go, but it's really annoying. So while I do the test process, I usually don't enable the piezo. But so let's go to the computer, and I'll go through the things they do in the code. Because I thought this was interesting. I don't have a library. I know SparkFun made a library specifically for, when they write testers, they have like a tester suite. I don't, and I could, but I don't. I don't know. I just copy and paste, the same code around. It is probably about time I should library file some of it because it's so common. But it's also really short, and it also does vary from board to board. I don't have the same tests. Like, I'll show you some things that are a little different about this design. So the first thing I do, of course, is, I set up the pin definitions. One thing that I like to do is, of course, I have the LED and the piezo, the indicator, but I also have the pins connected to the sensor itself. In this case, there's an IRQ pin and a shutdown pin. And then there's this 2.8 volt pin. So this sensor runs with a 2.8 volt regulator. You want to test the regulator, but that pin isn't brought out because I just ran out of space, and it's not that useful. So instead, what I do is I measure the interrupt pin, which comes out, and it's 2.8 volts. I also have an interrupt change thing. Whatever IRQs you have on the board you're testing, bring that out to whatever your test bench has as a hardware IRQ. This is a really easy way just to tell if something toggles. It's really hard to catch an IRQ because, of course, it's happening asynchronously. But if you have it connected up to one of the hardware interrupt pins on the Atmega 328, GPIO 2 and 3 are the hardware IRQs. That makes it easy. All right, so next up, I set up all the pin directions and make sure that's all set up. But most of the work is actually done in the loop. Why is it done in the loop? Because usually I want to retry. As people are pressing down the board, they might not get all the pins right, and so it might pass one or two tests, but not pass all of them. I like to just repeatedly test until it passes, and then, I usually stop. So one thing I do really like about the Atmega 328 series is these 8-bit chips are kind of dumb in a good way. I don't want my chips to be too smart because it actually gets in the way of the testing procedure. So one thing that's nice is that you can turn off the I2C peripheral by setting TWCR, which is 2-wire control register. You set that to 0 and actually disables I2C. And that means, because normally with Arduino, the Arduino programming language, when you start I2C, it enables the internal pull-ups on the I2C clock and data lines. But what I want to do is test whether the board has working clock and data lines. And so this is a kind of a nice little hack. I turn off I2C and it releases those internal pull-ups, and so I can then verify at the next step, I set the clock and data lines, which is A4 and A5, to inputs, and then check to make sure they're pulled up. That's a good first check to make sure is, I'm not checking if the chip is wired up. I'm not trying to connect over I2C. I'm just checking are the pull-ups enabled. Because one, if the pull-ups aren't enabled, it means that resistor pack didn't get soldered on. But also it's kind of lets you know when it's ready to start. Because I call these drop-in beeps. When people are testing, they drop the board on. They don't have to do anything to begin the test. It automatically starts when it detects those pull-ups.
What programming language is that? There's some folks that this is the first time they maybe even seen this. What is that programming language that you're using right there?
This is C++. It's Arduino, so I'm using the Arduino IDE. Why? Because it's very fast to get started and it's kind of universal. So when other people have to maintain these, the IDE is known, the tool chain is known. It's a very easy way to distribute code around. So I, like to use the Arduino core as my testing core, and then I'll make changes to it if I need something that isn't in Arduino. I have gone into the Teensy USB core and added like exposed some, VID and PID, number things because I was like, my tester really needs this, but it isn't exposed. I'll just go and do that rather than try to like start from scratch. But one nice thing is after I've built this tester, it creates a hex file. I just save the hex file in addition to the code, and then I can just move the hex file from board to board. And they're going to be making at Mega 328s until like the heat death of the universe. So I'm not worried about not being able to get these tester brains. Again, that's another really good reason to use a tester brain that's not necessarily inexpensive, but is long lasting.
Okay, do you test the strength of the pull-ups? The right resistors were soldered on.
No, I don't. That's not really a problem. You can do that, but I don't test absolutely 100% everything. Instead, I test what is the most likely things. And we really only place like 10K resistor packs, and I've never had those be the wrong values. However, it's not a bad idea. You can connect and disconnect external pull-down resistors, 10K, and then measure the voltage differential. But I don't really test that. I just test if the pull-ups are there. Because honestly, if I can connect over I2C, I don't really care what the value is, right? Maybe, let's say it was 4.7K, but if I can connect, then cool, right? If the value is too weak, I won't be able to. Okay, so once the I2C pull-ups are okay, I start I2C. And then a lot of the tester code is, how can you test multiple things at once and test all the hardware connections, right? You want to test the components and the hardware connections. So, this begin section is, of course, connecting to the sensor. So this tests actually multiple things. One, it tests the I2C connection because I have to connect to the sensor and measure that the sensor is powered. It measures that the sensor is the right sensor because if they place the wrong one, it wouldn't initialize. But I also am testing the shutdown pin. The shutdown pin on this sensor, it's kind of neat. You can use it to dynamically change the I2C address. This is common. People like to connect multiple chips on one I2C port. So as long as you initialize each board one after the other, you can change the I2C address. And so in this case, I set the address to be 40. And that's not the natural state of the I2C address. It's usually 29. And so if I can connect on address 40, I know that not only does the I2C connection work and the sensor's right, but the shutdown pin works, because if the shutdown pin isn't connected, it won't succeed in this. And one of the things I sometimes do to verify that I'm really testing it is, like, with my fingernail, I pull down on the pogo pin to keep it disconnected, and then I see it shouldn't pass test anymore. It's like I just kind of go through and I run the test, but I pull each pogo pin down, or I short 2 pins to make sure that they don't pass. Okay, so next there's testing the interrupt pin. So thankfully, interrupt pins are always, they're kind of annoying to test because, you have, what are you interrupting on? Whenever there is an interrupt polarity command for a sensor, I always throw that in because that makes it really easy, because you just set the polarity of the interrupt one way, check if it's high or low, flip the polarity and check that it's the opposite, and if that works, then you're done. I mean, you can continue testing the IRQ, but it's kind of it's like the easiest way to do it, so I like to do that. And then after I check the interrupt pin is high, which it should be on boot because that's the idle voltage, I can also test the 2.8 volt regulator. So this chip is powered by 2.8 volts, and my Metro is running at 5. And so I can, if I read the analog value of the interrupt pin, I should get about 2.8 volts or so. Don't turn on the internal pull-up. Instead, I'm measuring literally the voltage output from the IRQ pin. And then, if it doesn't work, I just continue. I then switch the polarity, make sure the polarity is low, and then I actually start communicating with the sensor, and I'm like, okay, get me data. I just sort of, technically this actually isn't necessary. I don't really need to do this, but I find it's kind of a good thing to make sure that the power is well connected. Maybe the capacitors are connected, because if the capacitors are missing, it's not going to be able to do the ranging because the power supply is volatile. And then I just, in a loop, I just take some measurements, and this is actually also where I check the interrupt GPIO pin. Remember I said I connected it to a hardware IRQ. I check that it changed. When you read data, it should be it should have toggled the IRQ to let me know that, and it's a good place to test it. And then on success, I set the LED to be high. I turn on the LED, and then you see I uncommented the piezo, mostly just to keep it nice and quiet. Another nice thing I do like about the, so you can see here, it going through the full test. Another thing I really like about the Atmega 328 based Arduinos, like the Metro 328, is that you can hit the reset button whenever you want, and it doesn't have this weird like USB disappeared, came back. It's much simpler, but it's also, I find, much more durable. I've got testers that have lasted 10, 15 years, easily. They're nearly indestructible. These chips and these boards are just, they will do the thing forever and ever. I really try to stay away from, I have Raspberry Pi based testers or computer based testers, but I really don't like them. I like to use something simple and embedded, like an 8-bit processor. Nothing ever really goes wrong with it. So that's my tester.
All right, there was one question.
Yeah.
That was, I think it might be related soon to the Great Search, but we'll see.
Yeah.
How do you recommend storing your microcontroller boards? I have a plastic case with slots I got from Micro Center, but I'm consider the best method. And then someone says, some people add anti-static sleeves and bags and more. But do you want to do the Great Search?
Yeah, that's a good time to go to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
All right, the Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. Every single week, Ladyada uses her powers of engineering for the last decade plus to find things on the DigiKey site. This week, this one came in from someone we know.
Almost, yeah.
And they said, hey, I'm looking for, a supplier for some anti-static stuff.
Yeah, so let's go to the overhead and I'll show what they're looking for. So they're making feather boards with headers attached. So like this Metro, it says Metro Mini. When you've got the headers attached, you really want to ship it with something protecting the headers. And you can use bubble, but nothing is quite as nice as anti-stat foam. You press it in and first off, it's extremely satisfying. It's got like a little ASMR thing going on there, and it doesn't move, it doesn't come out. It protects the pins, so you don't get something like this where it's like, oh no, pins get bendy, not so good. So they were asking like, well, how do you get anti-static foam? And it's one of those things where there's really actually not that many suppliers of it. It's not specialized, but it's there's only sort of like 3 companies that supply it, and it's both incredibly common, but like it isn't advertised. You know what I mean? Like it's like copy paper. It's like you know where to get it or you don't, but you're not gonna see ads for it necessarily. And so I thought I would show how to find anti-stat foam, and there's a couple different kinds, and you really want to make sure you get the right kind. You want this firm kind that you can,
It's like shopping for tofu.
Yeah, you want the firm tofu, not the soft tofu. I personally like soft tofu, but if you're stir frying, you want the firm tofu.
Yeah.
Yeah.
So you want to get a computer?
Yeah, let's go to the computer. Okay, so let's go to DigiKey. So the first thing you can do is just look for anti-static foam, which will get you some things. So there's static control devices. Now I will say that if you're going to use this, statistically speaking, statistically, you're not going to have as much ESD damage to your chips and boards as historical. Like sometimes people get really kind of like nervous and they're like, oh my god, you're putting chips in something that isn't anti-static, and oh my god, what are you doing? It's going to get damaged. For the most part, chips these days are way more durable than in like the 80s and 70s when they didn't have, built-in ESD diodes and the process was a lot more delicate. Nowadays, like chips, look, you can definitely destroy them, but it's just not as easy, right? They're much more durable. That said, if you're going to use foam, you might as well use anti-stat foam. And anti-stat foam is available both in pink style and black style. They're both the same. They're going to both work just fine. If you do need large quantities pre-cut, that's a separate service. I'm just going to show you where to get like gigantic sheets. Okay, so under accessories, it's the thing, it's under accessories, right? Not under grounding mats. So you can see, okay, we're getting close. But here's the thing. The problem with this is it's actually kind of hard to see what you're looking at because it's like, these are two different things, but they look the same. One of them is soft, and you can actually see, sometimes you get like super soft urethane foam, like it protecting a PCB. You're not going to be able to get the pins through this. It's actually just like it's just not going to sink through. So instead, first off, let's only look at active. Okay, hold on. And so the important thing is the specification. So there's thickness and specification. So the thickness, get whatever thickness is, you need, measure the headers that you want and then how thick you want it. But the most important thing is that if you want it to be the stiff type, you want it to be cross-linked. That's the name of the type. I don't think that the closed cell is I don't know whether the closed cell is the right kind, and I'm pretty sure it's not. But what I really like is 3/8 inch cross-linked. So let's look at all the 3/8 inch options. And then here's the thing. There's also the sheets available in 3/8. Let me add 5/16 also. Okay. So then, so there's this, but you can even kind of tell this is like soft and squishy. You gotta be careful. This is the conductive. And this also, I don't know if it's firm or not. This one definitely looks soft and squishy. It's cushioning guard. Yes, that's not going to be the right kind. So let's also look for what's in stock. Okay. So this one, soft, you don't want that. And this is also, you can tell it's soft, like you can even see the corners kind of bending. So the one you want is this. And what's nice is they even have a photo showing it in use. So you're like, yeah, that's what I want. You can see the chips are like plugged into it. And so they come in gigantic sheets, 2 feet by 3 feet. So because you're going to pay for the shipping, it's like a big box, you should get multiple sheets. Like I usually get like 5+ sheets at a time. And then they're really easy to cut with any scissors. And then what you would do is I actually recommend putting all the boards in, like on the large sheet, and then cutting them rather than trying to cut them into like small sheets or die cutting them and then pressing them. Although that can work. It's just, I find that the more surface area you have, the easier it is to plug it in. Otherwise, it's like when you're near the edge, you don't have enough material pushing up against the pins for it to plug in. Just if you go through this, you'll and you do that, you pre-cut the squares, you'll be like, oh, I remember she said don't do that because of this thing. That's very annoying. So I just recommend, you do what they're doing, which is, you plug everything in and then you cut the sheet. But you do get a large amount. You get, 6 square feet, which is like, a big chunk. So it's not cheap. It's like $50-$60. But you get a lot. And, I would basically buy 10 sheets that would last me like 6 months when I was doing kits. And I'd put chips in them, and you can put feathers in them. And then, of course, if you are using stacking headers, extra long headers, you don't want 3/8, you want 1/2 inch or whatever. Just measure whatever it is and add a little bit, and that's the thickness of the foam you want.
Okay, a couple questions.
Yeah.
First up, anti-static foam versus tubes, and then the second part of the question is anti-static foam from a few decades ago, would it break down after a number of years, corrode pins? Is today's anti-static foam any better?
I don't think it's going to be made much differently yet. I think it lasts a very, very long time, like decades. I've got foam.
I haven't heard anything.
I've never heard of any foam issues. I think the soft foam will break apart much sooner than this cross-linked stuff, which is quite durable.
I'm not quite sure civilization's going to last another 10 to 20 years from now.
You got other problems.
So that's future problems, but I think any foam is probably going to be okay.
Yeah, this is the stuff I use, and I think it's great. And this is from Conductive Containers, who I also we had on Iron and PI, and they make, they'll do custom stuff for you always. So if you do want stuff pre-cut or pre-shaped, they'll do it for you. Like you just have to order 10,000. But I just cut these with scissors, and it was great.
All right,
that's what I got.
That's it with the foam questions, and that is
foam.
Disc Ladyada.
Release the foam.
Where in the world is that part I need? The Great Search with DigiKey.
Okay, cool. Well, that was Desk Ladyada. That's
Thanks,
what I meant to
everybody.
say. And that was the great search for this week. Getting the show right in at 30 minutes, which we try to do.
Yay.
Thanks so much for joining us this Sunday evening. We have all of our shows during the week. This week, JP is hosting the Show and Tell. Should have all other shows going on as usual, and a lot more in store.
Okay.
So we'll see everybody next week, or we'll see you during the week.
Thanks, everybody.
Bye-bye.